Hello and welcome to this video on Venn diagrams, two-way tables, and probability. In this situation, we are looking at a restaurant called Fried Freddy's, where they have two main dishes, either chicken or fish, and then two preferences for cooking methods, either grilled or fried fish. So basically, Freddie is after 6 months, he's trying to determine why he's had so much more food waste, and he needs to get better at predicting how much he should prepare in advance in order to improve his business. So if you want to think about what they might need to understand in order to approach this problem, they would need to know data on past orders and how much was prepped for each one, and try to predict those orders going forward. So looking at our Venn diagram, we see that we have fried as one circle, fish as another circle. They have some overlap in the middle, and then we have a part on the outside that's outside of that. So keep in mind that we have basically two options for both of these. We have fish and chicken as the meal options, and then fried and grilled as the methods. So we want to look at what this Venn diagram first is telling us, interpret what these percentages are for. Because, well, first of all, if we do 20 plus 15 is 35, plus 30 is 65, plus 35 more is 100%. So within this square, we have our entire sample space, all of the orders by percentages from this restaurant. So first, if we know that our kind of purple circle, you can't really see that, but so this left circle is fried and the right circle is fish. If we wanted to label more specifically what the three pieces are and then this fourth piece outside are, so if I have something in this circle that's fried but not fish, well, that means this part of the circle has to be fried chicken. And so understanding it in terms of words is going to be important. On the right-hand side, if I have a circle of fish orders, but this part is a fish order but not fried, that means that this part of the circle has to be grilled fish. In the middle, that is where fried foods overlap with fish foods. So that would have to mean that this middle part is fried fish, is the overlap where you are frying your fish for your meal. Now, if I know that I've taken care of everything fried, everything fish, and both, well, that would mean that I'm missing chicken, and I'm also missing grilled as part of that. That would mean that this 35% right here would end up being grilled chicken. This allows us to better interpret what our Venn diagram is telling us. So now we know what each one of these four percentages is representing. As you might remember in class or otherwise, a two-way table is almost always going to be easier and more helpful to answer probability questions than a Venn diagram will be the majority of the time. So we're going to use our Venn diagram to fill in our missing percentages on our two-way table over here. So we know some of this information. We obviously know it's going to add up to 100%. So something I could do is, if I know that fried and fish, the overlap is 15%, I could find that intersection over here. Fried and fish would have to be 15%. So 15% of their orders are fried fish for dinner. So if we continue on, I can look at some other parts. So grilled and chicken, which was not included in our Venn diagram, grilled crossed with chicken, 35% would have to go where grilled and chicken intersect with each other. Then I can kind of fill in some more information from there. So if I want to know what percentage is total for fish, I just need to look at the whole fish circle in my Venn diagram, and that would be 15 plus 30 would be 45% of my orders would be fish. I know that 15 plus this blank has to equal 45, and that makes 30% for grilled fish orders. I can do 30 plus 35. That gets me to 65% of my orders. I know that blank plus 65 has to equal 100% of my orders, so that means this is 35%. 15 plus this blank would have to be 35%, so this makes it 20%. That's our fried chicken orders is 20% of the total. And then lastly, 20 plus 35 equals 55%. And that finishes our two-way table. And you can see that a lot of information not included in our Venn diagram is over here. Like we can tell right away that fish is 45% of the orders and chicken is 55% of the orders. And we can tell all the totals on the right-hand side as well. And we can see a lot more intersections. We know fried fish was 15% of intersection, but we also know that fried chicken intersection is 20% as well. So now that we've kind of shown both diagrams, we're going to use both of these diagrams to answer some probability questions on number 3 here to start with, and then on the back of the page as well. So for number 3, we have what is the probability that a randomly selected customer would order fish? So looking at our either diagram, we could look at our two-way table that we created from our Venn diagram. Well, 45%, easy to see there. Or we could do the middle, and the right side would be the total fish percentage orders. So right there, I know that 45% is the answer here. And if we wanted to use a Venn diagram and practice that idea, we could basically just shade in the middle. And we also, basically that's the 15 part, and then the 30 would be the part on the side. So if you have one of your Venn diagram, that would be this part of your Venn diagram. So the probability of one thing is usually the most straightforward. So finding the probability of fish wasn't too challenging for us so far. So let's keep moving. So as you can see up at the top there, I have recreated our Venn diagram and our two-way table from the above. And let's start with number 4 at the top. So it asks us, what is the probability that a randomly selected customer will order fried fish? So you look at the question itself, we see probability of fried and fish. That and right there, that's matching this symbol right here. So remember that symbol means intersection, and it is a math way in probability to write the word and. And an intersection basically mean the same thing. If you think about it in terms of Venn diagram, our two circles are intersecting at 15%. So continuing with the rest of this problem, we can look first, well, if I know that fried fish up in my Venn diagram, well, that intersection point is just 15%. So they are intersecting and 15%, and that would just be the middle here. So intersection is easy to see in a Venn diagram if you have your two circles as being those two, but it's also pretty easy to look at in your two-way table as well. If I need fried and fish, I'm looking at the fried row intersecting with the fish column. And so that would mean that this 15% right here out of 100%, that 15% out of 100% would give me the answer I'm looking for my two-way table. Next part of my problem is fried intersecting with chicken. So we have the same intersection notation up here, and we are basically looking at the intersection of those fried and chicken. So if we look at our two-way table, it's a little bit easier to see in our two-way table because we can see the intersection of fried and chicken, and we can see that we have a 20% number right there. So 20% is fried and chicken. very easy to see in our two-way table, but it's not quite so easy to see in our Venn diagram. So if we know that we're basically looking for all the orders that are fried and are chicken, so that would basically include none that are fish. So we don't want to include the whole right circle. And we want to include everything that is both fried and chicken. So basically it's fried, but not fish. So we could write it as fried, but not fish. In words right there. So thinking about it in words is always going to be easier. So fried, we know, is this left side. So that would be this left side of the Venn diagram, because we don't want to include this whole right circle. That whole right circle is fish. So we want everything that's fried but not fish. So this left side would be the chicken that's fried. So you can see that, like, if you look over at my labels here from the front page, fried chicken was that left half of that left circle. And so we have found that answer for number 5. So now in number 6, we have a same sort of problem. So now we have grilled and fish. Looking over at our two-way table, grilled row intersecting with fish column, that leads me to this 30% number right here. So that is going to be equal to 30%. So if we want to look at this blank right here, remember we're using our notation, so that's grilled intersect fish. That's that upside down U means intersect, it means the and feature. So if we are looking at our labels from earlier, well, grilled fish is up here. So the one way we could think of this, if we want grilled and fish, we basically want not fried and fish. So if I want to know what part of this is kind of the opposite of what we did before. So we want basically the fish circle, but we want to exclude the part that's fried. So we want to exclude this left part and only look at the right side of our Venn diagram, like so. So now that basically means that, well, that's only the fish. We've included fish, but we've excluded this whole circle that represents fried stuff. So we do not want fried, which we're excluding the left circle. We're including the right side, which is the fish part. But like I mentioned, much easier to see grilled intersecting with chicken. Grilled intersect with fish is 30% out of the total of 100%. And so that can show us like the percentages for certain amounts of the whole meals that are being ordered at this restaurant. And that leads us to number 7. So we have, say, 100 meals at lunch on a particular day, and Freddie wants to project how many of each kind of thing he wants if he's going to serve 100 lunch orders over the course of a business day. So if he wants to know, well, if I know the information from my Venn diagram, he wants to know, well, how many orders of fish should he prepare? So we already know that total fish orders from our Venn diagram or our two-way table, 45% is fish orders. So we're going to find 45% of 100 meals. Which, let's think back to our math in the past. Well, if I want to do that, find that answer, I got to change that percentage to a decimal, 0.45, and then multiply that by 100. And that means that he should expect 45 meals or 45 fish orders over the course of this entire lunch day. And that kind of takes care of applying that to the problem you started with. And you can do that with all of these. Like you could say, well, the rest of them, the 55% would be chicken orders, so that's 55 meals. And then he would know, well, how many fried meals, if he knows that 35% is fried meals, well, he should expect 35 orders to be fried, 65 orders to be grilled. And that gives us information, even though he only had certain information about fried and fish orders at the very beginning. Now we are moving to a slightly different and more complicated idea here in number 8. So let's straighten this out a little bit. Okay. Okay. So we have probability of fried, and then a little U right there, and then fish, and then next to it says fried or fish. So what that basically means is that U, well, more like a U like that, that stands for union. A union is basically a math probability theory way of saying or, like you see there. We're looking for how many people would either get a fried dish or a fish dish. So that kind of either or, you gotta think about what goes into that. So that means that they could order a fried dish, or they could order a fish dish, or they could order fried fish. And that would basically count for everything right there in this probability problem. So as far as that goes, well, we know that I can include all of my fried meals. And then I could include all of my fish meals. And that would cover the entire Venn diagram. But if you notice that we have a part in the middle that is both purple and blue. So we don't want to count that twice. So what we're basically going to do is add purple circle to green circle and then subtract out what that middle part is going to be. So our math for that is going to be purple, which is 35% is fried foods. And then I'm going to add the green circle, the teal circle, which is 45% of the meals are fish. And then we just have to subtract the middle part, which is going to be 1 of the, basically where it's both. And that is going to be subtracting 15%. And that means that our answer, 35 plus 45, gives us a grand total of 80. 80 minus 65, or 80 minus 15% would be an answer of 65%. So that's kind of a little bit of the logic behind it. Also, if you have your Venn diagram set up, you'll notice that 20 plus 15 is 35, plus 30 equals 65% as well. So when you are going to be doing this, something to write down, this is basically called the addition rule that you may have saw in our first video. So what you need to do, if you're going to find the probability of, in this case, fish or fried, you need to do the probability of fish plus the probability of fried minus the probability of fish and fried. We don't want to count this twice because it's part of the fish dinner order or lunch orders, and then it's also part of the fried lunch orders. So we only want to use it once, so we got to take it away once, basically. If we wanted to write that in kind of the more fancy math way, you basically are doing probability of A union B equals the probability of A plus the probability of B minus the probability of A intersecting with B. So that's your formula. And this, remember, only happens if you have overlap. if there's no overlap at all, if there were no overlap between fried meals and fish meals, you wouldn't need to do this because then they would have no intersection at all. So then you'd just be -0 in that particular case. And these basically have what are called joint probabilities because they're kind of connected there. So this right here is called the addition rule. The addition rule. So lastly, we are going to do number 9 at the very bottom. So it's asking about the probability that a randomly selected person would not choose fish or fried. So this is basically, since we see the word not, that's kind of the opposite of what we just fried, not fish or fried. So if I wanted to do probability of not fish or fried, all I have to do is 1 minus the probability of fish or fried. And in this case, you basically are shading in everything that is not included in the Venn diagram that we've been working on this whole time. We already know that's 35%, but we also could do 1 minus the answer we just got, or really do 100% minus the answer we just got, and that gives us an answer of 35%. And lastly, a note here is that when you're doing something like this, the probability of something not happening, that is, we mentioned it before in class, is called the complement. And a complement is basically just, and I can write it right here. So the probability of something not happening is just 1 minus the probability of it actually happening. So that concludes our ideas here and our classwork for this part of our probability chapter. We've talked about making Venn diagrams and make them into two-way tables to aid ourselves, and then finding various different probabilities, whether it be the probability of fish by itself or probability of two things together intersecting with each other, and also probability of a union, which was adding two things together, one or the other, probability of fried or fish, for instance. And you could do that with all kinds of other things in this same topic. And lastly, we went over what a complement is. You find the complement by just finding the probability of something not happening, and then basically finding that by just doing 1 minus the probability of it happening. And that concludes our video today on Venn diagrams, probabilities, and two-way tables. Thank you for watching.